Welcome back to the Cave of Science, and today we're looking at monatomic and polyatomic ions. The first group we're going to look at are the monatomic cations, and they fall into two groups. And these two groups are those that have a single charge and those with multiple charges. The first group, you would name them, you would just say the element and then the word ion, such as the sodium ion, the aluminum ion, and the calcium ion. And these ions are found in group 1A, the alkali metals, and they all have a positive 1 charge. Group 2A, the alkaline earth metals, positive 2 charge. And the other metals included in this are zinc, aluminum, and silver. The other group are the monatomic cations, are going to be the ones that can have more than one possible charge. And the charge must be designated by a Roman numeral in parentheses suffixed to the name of the element. So what do we mean by that? We'll take a look at some of these. So here we have the cation name. Notice chromium. Again, you would just name the element. It's chromium 2 in parentheses for positive 2 charge, chromium 3 in parentheses for chromium 3 charge. Manganese, you can see the 2 there. Iron, a very common one, iron 2, iron 3, cobalt, copper, mercury is another one. Mercury 1 gaseous ion, you don't see a whole lot, so you may run into it once in a while. Tin has 2 possible ones, tin 2 with a positive 2 charge, tin 4 with a positive 4 charge. You run into lead a fair amount, lead 2 with a positive 2 charge, and lead 4 with a positive 4 charge. So again, to name these, you would just name the element, and then you would put the charge in parentheses in Roman numerals. And there are many different charts available with these ions on them. Monatomic anions, or the negative ions, is the stem of the element and then the suffix IDE. So you get a couple examples. Chlorine would be the chloride ion. Another example would be the oxygen ion would be oxide. And monatomic anions do not have multiple charges. So again, some other ones, if you look on there, be the fluoride would be the, or fluorine, which would be the fluoride ion, and so forth. So these again do not have multiple charges on these. They are monatomic anions, and they just have a single charge. Typically, you're going to find them with a -1, -2, or -3. Polyatomic ions, on the other hand, they consist of more than one atom. For example, the nitrate ion, NO3, with a -1 charge, contains 1 nitrogen atom and 3 oxygen atoms. The atoms in a polyatomic ion are usually covalently bonded and stay together as a single charge unit. So which is kind of nice. You'll find charts of these also. And when you look at these, they just remain as a single unit with a single charge. Now, when you name polyatomic ions, they're often referred to as oxyanions. You may run into that term, you may not. But the most common name of these are given the ATE ending. Sulfate, nitrate, the bromates, and so forth. Well, there are some variations. So if the oxy ion has the same charge and 1 more oxygen than the 8, then it is named by adding per to the prefix to the name of the 8 ion. And we'll look at some examples of this in a minute. If the oxy ion has the same charge and 1 oxygen less than the 8, then it is given an ite ending in place of the 8. If the polyatomic oxyanion has the same charge and 1 oxygen less than the ite, then it is named by adding the hypo prefix to the name of the ite ion. This sounds a little difficult to go through, so let's just go through some examples here on a polyatomic ion chart. And again, there are many of these charts that you can find. You can Google them, and I'm sure you'll get some in your classroom and so forth. So let's look at the ones that on the top left here of our polyatomic ions. So the ATE ending is the most common. So we have bromate with a -1 charge. If we have one more oxygen or an O4, it becomes perbromate. But notice the charge doesn't change. It's still a -1 charge. If we look at the ATE ending, which is O3, and it has one less oxygen, O2, it is bromite. If it has one less than bromite, it is hypobromite. So we can look at another one here. Let's look at, I guess we can look at the chlorate. So the chlorate, ClO3, has a -1 charge. So if we look at one more oxygen, so we go from 3 to 4 oxygens, it's perchlorate. Again, one more oxygen, it's the per gets added as a prefix. If we have one less oxygen than the ATE ending, it becomes ite. So this would be chlorite. And here, if you look, we have one less oxygen than the ITE ending. And if you look on the chlorite, we see it just ClO. It is hypochlorite. So really, once you start looking at these, they're really not too difficult to remember on these. There's the iodate, again, is a common one. Nitrate, looking in the middle there, NO3 -1. You'll run into the nitrite, which is NO2. Notice it still is a -1 charge. Some other common ones you have in there, hydroxide, you'll see a whole lot. The other big one, acetate, C2H3O2, -1 charge. Permanganate, you'll run into MnO4 with a -1 charge. Notice we do have some with a -2 charge. Carbonate, phthalate, I'll be honest, you won't run into that a whole lot. You will run into sulfate. Sulfate is a pretty common one, SO4 with a -2 charge. And if we move over to the right, you'll notice sulfite has a -2 with a SO3 formula. Again, one less than the SO4. And -3 charge, you have phosphate, which is the common form. One less oxygen would be phosphite. Now, for our polyatomic ions go, they all have negative charges with one exception, and that is the ammonium ion, and that is the NH4 +1. That is the only positive polyatomic ion you're going to run into, such as you might see the term ammonium hydroxide, NH4OH. And so the ammonium ion, NH4, is the only polyatomic ion that has a positive charge. The more you play around with these, the better you get. The ones you're going to see the most, you're going to see the polyatomic ions with the ATE ending, but it's pretty simple to remember which way to go. If you have one more oxygen than the ATE, it's a per. If you have one less, it's an ite ending. And if you have one less than the ite, it's a hypoite. So again, hope this, take a look at these. Again, there are many, many charts out there you can get. So until next time.